Hello, my name is Mohit, and I'm going to demonstrate the experiment 1 of the assignment in the cybersecurity. So, in this experiment, I demonstrate the exploitation of Java RMI vulnerability using the Metasploit Framework. Java RMI, or the remote machine invocation, allows a Java program to invoke method of another Java object using a network using serialized objects. If the RMI service does not properly validate incoming serious data, it becomes a vulnerable to deserialization attack that can lead to the remote code execution. So, for this experiment, I created a control environment. I installed the Kali Linux OS as iOS, as you can see from this website. I installed the ISO, and I have also installed the Metasploit table 2. It is in this framework, and I have used the Metasploit as intentionally the vulnerable target system. Since I am using the Apple Cynical system where the VirtualBox does not support the x86 cache system, which is the Metasploitable to have, so I ran the Metasploit using the QEMU, using my terminal, so like this. So this is the command I used use the Metasploitable to run. So this allows the vulnerable Linux system to run correctly on the ARM architecture. Both machines were connected through a host-only network configuration. I will show you. So this is the network details about it. There's a adapter. This is the host-only network I have created here. So this is the host network. There's a marks and lower bound. This is the IP of it, 192.168.56.1 of this. Both machines are connected through a host-only network configuration, and the host-only network creates an isolated private network between the attacker and the this attacker VM that is present here, and there's another VM which is in my terminal. I'm going to run again using this command. So this will create a new QEMU. Using the QEMU, it will open the Metasploit table. So this ensures the all exploitation remains confined within the lab environment, maintain the safety while simulating a realistic attacker victim scenario. So after verifying connectivity and confirming the Java RMI service in the running port 1099, I will proceed with the exploitation part. First of all, let me see what happened in the Metasploit table. So port 1099 is the default port of the Metasploit table. So this is the Metasploit table. I will run it again to show you. So this is the port. It will open. While this is opening, I will show the IP of the Kali attacker. So this is the Kali attacker. I will run the command IPA, which will show me the IP 192.168.56.2. So this is the IP of the Kali VM. So what is going to happen? We are connected to the network of host only network. So this host will connected to the VBox net, which we have made the network. Then VBox net will forward this network to the IP of our that QEMU Metasploit table. That is around 10.0.2.1.15. I can show. So this is the MSF admin. MSF admin. If I run the command ifconfig. So you can see there's an inter address of the 10.0.2.15. So what is going to happen is there's a two-layer system will work. So this IP will connect to the host only network for the 1.68.56.1. Then that will forward to the connection of the 10.0.2.115 of the QEMU. So this is the IP. Then I will show how the attacking system will go to work. The step one is the reconnaissance using the Nmap. So before launching the exploit, I perform the reconnaissance using the Nmap to identify the open ports and running services on the target system. So I have run the command this Nmap 1099.192.168.56.1, which shows that port 1099 is a default port for the Java RMI. This indicates the target is potentially vulnerable to the RMI-based decentralization attacks. After successful mapping, I've run the command of MSF console. I start the Metasploit framework, which provides a database of exploit modules and payloads. Using the command, that it will open the terminal of the MSF. So I've run using the command use exploit misc Java RMI server. This module targets the insecure RMI service with the decentralized unstructured objects without validation. The step 4 will be the configuration of target parameters. So this is the so we have to show the R host, R port, payload, L host, and L port. R host specifies the target system. R port is the 1099 because that is where the RMI registry service is listening. After that, we have load the payload. The payload is the Java reverse TCP Metasploit shell. LOS is set to the attacker machine's IP address, and L port specifies the listening port for the reverse condition. After setting all the details, we can verify using the option of show options. So you can verify the R host is this, R port is this, L host is this, L port is this. This is the verification of it. So after all verification, we will exploit using the commands of exploit. So after the exploit sends a malicious serialized Java object to the RMI service, because the RMI service does not properly validate incoming serialized object. It deserializes the executes and the payload. So the victim machine has executed the payload and established a reverse connection back to the attacker. So this attack is currently successful. We can see the command the get UID give me the root, which is of the Metasploit table is in the root one, and the get UID system info gives me the Linux 2.1 server, which is the Metasploit table. The computer here shows Metasploitable OS is the Linux 1 architecture is x86. So it shows that it successfully exploit our Metasploitable VM. So this is how the exploitation is done. Thank you.